Welcome to JD's Prep. All right, so here we have a lab exercise, which is measuring the effect of acidic pH on the rate of the reaction of H2O2, so hydrogen peroxide, with catalase. Catalase breaks down hydrogen peroxide and produces water and oxygen gas. Okay, so let's look at the table that we've been given. Okay, so pH level goes from 7 to 6 to 5 to 3. So as pH goes down, if we look in this next row, so as pH is going down, reaction rate is also going down. So 1.5, 1.3, 1.55. So pH goes down and reaction rate also goes down. And by extension, when pH goes up, reaction rate also will go up. Okay. Looking at the graphs, we're looking for the graph that most accurately represents the results obtained by the student. Obviously, these don't have really specific scales, so we're just looking for a trend here. And we want to see a trend where pH goes down, reaction rate goes down, pH goes up, reaction rate goes up. So there's a couple that are fairly obviously wrong. This guy right here, this guy right here. And then these two both have that kind of really basic linear relation, but this number one shows that as pH goes up, the rate of reaction goes up. So that is our answer. On to the next question. All right, so which conclusion is valid based on the data collected by the student? So let's just go through and eliminate where we can. Okay, a change in pH prevents catalase from breaking down water. Catalase breaks down hydrogen peroxide, not water. So that one is not what we're interested in. This last one, catalase caused the greatest production of oxygen at pH of 3. That's actually where it was lowest. And number 3, we're also going to eliminate because oxygen production won't increase if more water is added to the reaction. Water is also a product in this equation. Okay, hydrogen peroxide is broken down to water and oxygen. So that leaves us with 2, which makes sense. Catalase has the greatest activity at a pH of 7. At the pH of 7, that's where we have the highest reaction rate. So obviously catalase has the greatest activity there. And we'll finish off with this question, asking about the best explanation for the change in catalase activity as the pH changed from 7 to 3. So the pH change from 7 to 3 is an increase in acidity. Okay, so let's keep that in mind as we go through. Okay, so strong acid going from pH 7 to 3 is definitely strong acid, but the reaction rate does not increase when we go down there. Okay, this doesn't have anything to do with cooling the H2O2 solution. There's no reason to believe that. And this last one we're also going to eliminate because decreased oxygen production causing catalase to increase the rate of reaction is just a loop that doesn't really make sense. So 3 refers to the fact that in acidic solutions that strong pH can change the shape of catalase. So it can actually change the shape of the enzyme. And then when that shape of the enzyme changes, its ability to perform the reaction that it does decreases as well. So number 3 makes a lot of sense. All right, thank you for using JD's Prep.